Welcome back, everyone. I hope you had a chance to, in this short break, at least it's like a body break, get something quick to drink or to eat, so you can get ready for the next set of amazing presenters. The first presenter up is Dr. Schalk Grobbelaar. Schalk Grobbelaar received his PhD from the Graduate School of Technology Management, GSTM, at the University of Pretoria in 2019. He's currently a senior lecturer at the GSTM. Before joining them, he was the group engineer at York Timbers Pty Limited. During his time at York Timbers, he was responsible for engineering management and project management. He's lecturing technology and innovation management and risk management to postgraduate students. His interests in research are innovation strategies, risk management, and application of artificial intelligence. Thank you, Dr. Grobbelaar, for being here, and I'm going to hand over to you. I'll let you know about if you've got 5 minutes left and 1 minute left, just for in case.
Okay, well, thank you, Courtney. So yeah, this presentation is basically started. I presented risk management to the postgraduate students at the GSTM this year, and one of the key aspects that I wanted to illustrate to them is the influence of uncertainty on a system and the importance of considering it. So one area that I wanted to include in the course material was operations risk management problem. And the idea was to illustrate how the Monte Carlo simulation can be used to get a better understanding of the uncertainty in the operations type of problem. So the task to the students was that they had to prepare a budget for their company using operations research problem and the Monte Carlo simulation. The challenge with most Monte Carlo software is that it is not free to use, or that it's got limited capabilities. So what I wanted to do is to create an open source model that they could use to do Monte Carlo simulations and to test the material. And hopefully through testing the Monte Carlo simulation, they would get an idea of how it works and then maybe use it in future. So I did some research, and the challenges with Excel as it is there's a couple of statistical functions that is not included in the standard Excel version that is useful when creating Monte Carlo simulations. You can probably create a very basic Monte Carlo simulation using Excel as is, but there are a couple of functions, and when I go through the presentation, I'll point out some of the functions that are not available in the standard Excel. So what I realized when I was researching the problem is that there is a add-in for Excel that is free. It's called Real Statistics using Excel, and my presentation is about how I use this add-in in Excel to create a operations research Monte Carlo simulation. So what I wanted to illustrate to the students is that in any organization or process, you've typically got uncertainty in terms of the input. The raw material is not always the same. There's differences in costs, availability, so things change. And a system also, how it interacts with the raw material is variable. It's not constant. And then because of that, there's a high amount of variability in the output. And the question is how much variability is acceptable and what are the thresholds. In my experience, in most companies, what we typically do is we take the average or the thumb suck value and we put that in as the budget, and then we basically never make the budget, and we then try to explain it away, or when things are not, if we do better, we're obviously happy and we say we had a good prediction, and if it's worse, then we try to give excuses. But I think what we tend to forget is that any system is inherently uncertain, and it's important that we consider the uncertainty and whether it's acceptable. So in terms of a bit of a background, the Monte Carlo method was first presented in 1949 and later popularized in 1964. The model that I used was a relatively simple process flow diagram. So basically raw material going into 3 manufacturing processes with buffers in between the 3 processes are considered OEE, and then also recovery. And a lot of this model was based on my experience in the sawmilling industry. And because we typically used models like this, for example, the process 1 would be the wet mill, and then between the next process would be the drying process of the wood, and then the last process would be, for example, planing or the dry mill, and then that would go into finished goods. And typically through the whole process, you lose raw material. Sawmill recovery is in the region of about 50%. But it is variable. So I try to illustrate all of these aspects in the model. Then in terms of the availability, the add-in that I use, this is the website or the link to the add-in. It's basically a statistics add-in, but it's got useful functions for the Monte Carlo simulation. It's free. It's got very useful information about estimating variables and how to build models in Excel. So the approach that I basically took is that there were a couple of variables, for example, production capacity. And for each of these variables, for example, production capacity, raw material cost, or selling price, or fixed cost, the model allows you to estimate a triangular distribution by estimating the optimal value or the lowest value, not always the optimal actually, the most likely, and then the highest value. And then through running a Monte Carlo simulation for each of these variables, the outputs are combined into a profit model expectation. And for this specific Monte Carlo simulation, each variable had 1,000 simulations. So here is a graphical interpretation of the approach. So again, for each aspect, for example, the cost, the inputs would be a low value, a most likely value, and then a high value. And the triangular distribution is already a function that is not available in the standard Excel. So that was the first function that I used from the add-in. And then the second function is the cumulative distribution of the integral of the triangular distribution. Then what is quite useful when you have these additional functions is you can calculate the inverse of the cumulative distribution function. And for a Monte Carlo simulation, this is specifically useful because you can use the random function in Excel to create a random variable between 0 and 1, and then based on that, estimate a cost using the cumulative distribution function. And if you run enough simulations, you will get a continuous graph, or close in any case. In this case, I only ran 1,000 simulations. Obviously, if you run more simulations, you'll get closer to the actual value. So this is the illustration of the inputs. So for example, to keep it simple, the model can run between infinite buffer or no buffer. And you can estimate process capacities, overall equipment effectiveness. This was averaged over the 3 processes, just to keep it simple. And then using the theory of constraints, the bottleneck was calculated. The inputs for the material cost, the recovery, and other variable costs can be varied. Selling price can be varied, the production time, and then all the fixed costs. And then the important thing is the budget confidence. This is an example of the output typically created from this the model. So it creates a histogram of all the potential results, and then using the expected confidence, you can indicate that that's more or less the expected profit for that process. The important thing that I built this specific. Oh, sorry. No.
Sorry, Schalk, just saying 5 minutes.
Yes.
5 minutes.
Yeah. No, I'm almost finished. So, so the important thing that I wanted to illustrate with this model specifically, and why I chose it as it is to illustrate in this specific case, even though most companies would take that as typically their budget, they won't necessarily consider the variability in the system. And if you look at this system, there's a massive amount of variability because the profit ranges from 700,000 to 8 million. Now, I know this is a hypothetical example, but in my experience with the sawmilling industry, in any case, that's about how much variance there are from what the expected budget was. And typically the question that I would then pose to the students is, where would you focus? Would you focus on increasing capacity, reducing costs, or reducing variability? And I think in this case, as an example, variability is a big problem in the system. So some limitations of the specific model, and it was just to teach the students a bit. So the idea was not to build a model that will be used for commercial gain or any thing like that. Is firstly, it was I used a 2-parameter Weibull distribution, so I couldn't simulate a negative profit, which would have been nice to be able to do. I think a 3-parameter Weibull distribution would solve that problem. The model assumes steady state. It ignored the cost of work in progress. I've built limited error checking in. It assumed independence of variables. In many cases, variables are at least correlated, so I didn't build that in. Average OEE was used, which assumed mutual exclusivity. Then, in conclusion, for system models, variability is an important consideration. The Monte Carlo simulation is quite useful to do this and can be used to prioritize control plans. It is ideal for use in risk management courses, and since it's a free tool, students can apply the model and experiment with it in their own time. Future developments might include additional input distributions, 3-parameter Weibull, and comparing the results with commercial software to see how reliable the outputs are. And yes, that's my story. Any questions?
Thank you so much, Dr. Schalk. This is really interesting. I think I didn't even know about this program that's in Excel that you can actually just, you're saying it's free and you can actually download it and install it on your own Excel at any time.
Yeah, so the model obviously I had to build, but the add-in is for free. So you can real statistics. There was a couple of glitches with the add-in that you have to activate it every time you open Excel, which is irritating. But it works, and it's got a huge amount of Excel statistical functions that's not usually available in Excel. So yeah, if you like modeling in Excel, I strongly recommend viewing that site and maybe adding the add-in to your capabilities.
Thank you, Schalk. I find it very interesting also the graph you showed and your results. Is that like the upper end of that value? That's where the cost can actually run to, right? If I understand correctly, something like 8 million rand.
Yeah, so in that case it was profit. So what I wanted to illustrate is the profitability of a company. So yeah, and again, in my experience, it can actually happen that I've been in sawmills for some time, and I've been in many budgeting exercises, and we've missed the budget, not by small margins, not with 5%, 10%. I'm like double or half or type of thing. So, and the question in a situation like that is, should you, if you do an investment, should you invest in additional capacity, or should you look at where the variability is and try to control that? And I think we, in my experience in any case, we tend to ignore the variability and to improve the control.
That's a very good insight. Thank you for sharing that, Scott. So if there's any questions, please, you can raise your hand. You can post in the chat. The best is to raise your hand or just unmute and talk. I would like to hear any of your questions. But this is very interesting, Scott. It's something that in like when I did my final year design as well, they tell you you do all this work to define the cost, but then in the day it will be like something like 20% accurate. Doesn't matter how well you actually do that. So a model like this could be really useful to actually, give you a bigger picture of, it's not going to be this, it might be a range of profits.
Yeah, the thing is, what we typically assume is what, and I built a similar model for Cozy where we look at projects. So what we typically do in projects is we combine all the averages and then we add a contingency. And the same with budgeting for companies. We ignore the variability within each component of the system and how that can combine to have a much bigger effect. And that's what makes the Monte Carlo simulation so useful, is you can see how those combination of effects collaborate to create a very uncertain system, which we tend to ignore.
I like how you said it just now, like each one of those components have like variance to them, but just taking an overall variance doesn't give you a picture. You have to actually look at those individual components and see how those are affecting the bigger ripples that we'll see at the end of the day.
Yeah.
Maybe my last question is, your students, how did they receive this project? What did they learn? What did they tell you from this experience? What did they learn? What did they take away?
Yeah, so I had it's an interesting story actually. Is one of those moments where the lecturer makes mistakes and then he tells the students, "I was testing you." So what happened is I made a mistake in the model, and then when I presented to the students and I did a live demo, and then, for example, I didn't, at the time I forgot that a 2-parameter variable can't give a negative result, and I tried to simulate a negative result to them, and then suddenly it didn't work, and I had to figure out why it was. So I presented it in 2 classes. So the first class was a bit confused because of the mistakes that I made, and then the second class I think went much better. The students, I think, that like modeling, they really appreciate it, because what the assignment included was that they had to apply it in their company, and I was actually surprised at how many of the students did a very good simulation of their company, and also the interpretation that they did was quite interesting. So yes, I think I think when you're a lecturer, you always wonder whether the students learn something. So my conclusion is that some of them learn something. I hope that makes sense.
That is the best that you can expect, right? So that some people learn. Not everybody will take it on, and that's the thing about teaching. But thank you also for being honest about the mistakes. I think we all make mistakes, and being honest about that actually helps us grow even more. And I mean, that's also good that students picked it up. Be like, hey, something's not right here.
Yeah,
that's good. So thank you so much, Dr. Schalk.
Okay, it's a pleasure.
I appreciate that you're here, and thank you for teaching us this concept.